Okay, we are going to start by going over what we were introduced to yesterday and verifying that we have the takeaways that we should have come out with from our Desmos activity. So the first thing we're going to do is we're going to look at deriving y equals mx plus b. So when we're deriving y equals mx plus b, the first thing we're going to do is we're going to look at a line on a graph. This is just my 4-quadrant graph, and I have a point here. This point is 0, comma b, and let's just say this point over here is x, comma y, and they are connected something like this with this line going through. Okay, so when we're deriving this first thing we're going to do is step 1. We are going to begin with the slope formula. And as a reminder, the slope formula is m equals y2 minus y1 over x2 minus x1. We could also look at this as delta y over delta x is equal to m. Next thing, after we have our slope formula, we are going to step 2, which is substitute the points. So my first point here is 0, comma b, and my second point here is x, comma y. What we're going to do is we are going to go ahead and call this x1, y1, and this is going to be x2, y2. So I write my formula, m equals y2 minus y1 over x2 minus x1. M equals y2 is y minus y1, which is b, all over x2, which is x, minus x1, which is 0. Then from here, what I'm going to need to do is I'm going to go ahead and go to step 3, which is simplify. So I currently have m equals y minus b over x minus 0. First thing is I'm going to fix this denominator. So I have m equals y minus b all over x. In order to get rid of the denominator, I'm going to multiply by the reciprocal. So I'm going to multiply both sides by x over 1. I now have mx is equal to y minus b. I'm trying to isolate y because I'm solving for y, so I'm going to add b to both sides. I have y equals, because this is a 0 pair. None of this is the same, so I have mx plus b. That is not typically the order in which we write, so I'm just going to go ahead and clear that up as y equals mx plus b. There you have it. That is how we get slope-intercept form, which was the y equals mx plus b that we took away yesterday from our Desmos activity. So let's talk about slope-intercept form. Slope-intercept form is going to be like our new best friend this year. We're going to use it for like everything from here on out. So again, that is y equals mx plus b. We have learned and just went back over m. M is our slope. We can also look at this as our rate of change. So that should feel familiar in terms of course 2, rate of change. B, this right here is my y-intercept. My y-intercept is going to be where the line crosses the y-axis. We would call this a point on the graph, so it must be written as such, which is 0, comma b. B would be substituted with whatever number the line is touching on my y-axis. We also refer to this as the initial value. Okay, any of those things. So let's go ahead and look at some examples. Here is example 1. Example 1, we're asked to name the slope and y-intercept. So on number 1, I have y equals 5x plus 3. One of the things that I personally find helpful sometimes is to write out the equation, the form, slope-intercept form, to start from. So that's y equals mx plus b. So now that I've written them side by side, I can easily see that my m and my 5 line up together, and my b and my 3 line up together. So now when I need to identify my slope, I would say my slope is going to be 5. And when I look at my y-intercept, that's my b. Remember, though, I need to write it as an ordered pair. So when I'm writing it as an ordered pair, I need to write this as 0, 3. And that pretty much is it. So here is number 2. This is y equals negative x plus 5. Again, I'm just going to write y equals mx plus b next to it so I can see where things are lining up, which makes it easier for me. This negative is not just hanging out here. This is the invisible math that we have talked about in the past. That is representing a -1. So here my slope is going to be a -1, and my y-intercept is here, and I'm writing it as the ordered pair, so that's 0, 5. So that is how to identify slope and y-intercept from slope-intercept form, which again is y equals mx plus b. Then we're going to do one more example together. This example is example 2. And example 2 says, write an equation with slope of -3 and a y-intercept of -4. I think that when given a problem like this, it's easiest to start by identifying our slope and our y-intercept. So in this case, slope of -3. So my slope here is -3, and my y-intercept here is going to be -4. So I just pulled those from the problem. Now at this point, I'm going to write down slope-intercept form. So slope-intercept form is the y equals mx plus b. As a reminder, my slope is also known as m, and my y-intercept is also known as my b. So essentially, all I have to do here is go ahead and substitute in for those two values, and I have my equation. So y stays. I'm going to substitute in -3 times x, and then this is plus b. This is a -4, so I'm just going to write -4. There you have it. I have written slope-intercept form. Pretty straightforward. Very important, though, and this is something that we will use for the remainder of the year and also in classes going forwards. So it's important that you have a very clear understanding of this. So that is slope-intercept form in a nutshell.